In this 12th podcast, we're going to be looking at balancing chemical equations. So we know that chemical reactions occur between different substances, and the result is that a new substance or new substances are made. Essentially, we've got reactants, and they react to make the products. Now, we did an experiment based around conservation of mass or conservation of matter, and that tells us that all the substances and all the atoms present in the reactants must be accounted for in the products. If we have 10 grams of reactants, we're going to have 10 grams of products. So all the atoms are accounted for. So when we're looking at balancing chemical equations or the equations of chemical reactions, we've got to ensure that all atoms are present on both sides of the equation. Now, a while back we were looking at baking soda and hydrochloric acid reaction, which fizzes nicely, producing carbon dioxide, and this is the equation that we wrote down. Now, I've color-coded this to show the different atoms on the left and on the right of the equation. So we can see that on the left, sodium, one atom of sodium, also one atom of sodium on the right hand side of the equation. The arrow in the middle represents the transition between the reactants and the products. Hydrogen on the left, 2 hydrogen atoms, and on the right H2 indicates 2 hydrogen atoms within this water molecule here. Carbon, 1 atom here, 1 atom here. Oxygen, O3 indicates 3 atoms of oxygen here, and we've got 3 oxygen atoms here divided up between the carbon dioxide and the water. And finally 1 chlorine atom, and the chlorine atom is accounted for over here in the sodium chloride on the right. Now, this equation is balanced. As you can see, all of the atoms on the left of the equation are accounted for on the right hand side of the equation. We didn't need to do anything to the equation to balance it, but not all equations balance quite so easily as this. Let's take a look at water. Now, we can make water by burning hydrogen gas in oxygen. Water, as we know, is H2O. Now, the word equation for the production of water would be hydrogen plus oxygen equals water, or becomes water. The symbol equation would be hydrogen, so that's H, plus oxygen, that's O, becomes water, and we know water's H2O. But there are some problems with this equation. This equation is not right for several reasons. So let's take a look at some reasons why. So firstly, the hydrogen and oxygen are called diatomic gases because that means they form molecules with each other, with themselves. So we have a hydrogen molecule and an oxygen molecule, each with 2 atoms. Hydrogen forms a molecule with 2 atoms, 2 hydrogens, and oxygen does the same thing. So we have H2 plus O2 becomes H2O. So we've solved one problem. We've solved the problem that the hydrogen and oxygen gas was not actually written correctly in the first place. Just linking back to the previous podcast, we know that the bonds between the atoms within these molecules are formed covalently in order to fill the valence orbitals for these atoms. There's a single bond between the 2 hydrogen atoms here, and there's a double bond between the 2 oxygen atoms. But let's move on to balancing the equation. So it's not balanced. We can see that because on the left we have only 2 hydrogen atoms and 2 oxygen atoms. On the right we have 2 hydrogen atoms, that's okay, but we've got 1 oxygen atom. So there's a problem here. There seems to be not enough oxygen atoms on the right. Now, we can't just go ahead and do this. That's not right, because H2O2 is not water, it's something else. So we can't go changing the compounds in these chemical reactions. So what we must do is change the number or the amount of the of the substances involved. We can put a number in front of the compounds to change the amount we have. So on the right hand side here we don't have enough water to match the amount of oxygen, so we must put a 2 in front of the water molecule. Now we have enough oxygen. 2 molecules of water have 2 oxygen atoms. However, 2 molecules of water, unfortunately, has 2 times 2, 4 atoms of hydrogen, and we only have 2 atoms here. But that's an easy fix, because all I need to do now is put a 2 in front of the hydrogen, and I have 4 atoms of hydrogen here. 2 molecules, each molecule has 2, that's a total of 4 atoms of hydrogen, 2 atoms of oxygen, 4 atoms of hydrogen, and 2 atoms of oxygen. So that is balanced. Now, we can only balance equations by changing the number preceding the compound. As I just said, we can't change the suffix number because that would change the actual compound that we have. So we can only change the number preceding it. That represents the amount of compound that we have. More about that later on. So let's see about balancing some other equations. Magnesium plus oxygen. If we burn magnesium in oxygen, we get magnesium oxide. That's the word equation. This is the symbol equation. Now let's take a look at that. We have 1 atom of magnesium here and 2 atoms of oxygen. Clearly on the right we've got 1 magnesium and 1 oxygen. So similarly to the previous example, I'm going to solve the problem I have with not enough oxygens and double the amount of magnesium oxide that I produce on the right. Now I have 2 oxygens, but I have 2 magnesiums. So what do? I need a 2 here. Now I have 2 magnesium atoms, 2 oxygen atoms there, and on the right 2 magnesiums and 2 oxygens. Balanced. Let's take a look at another one. Potassium plus water. This is a reaction we're going to see in the near future. Potassium is an alkaline metal. Makes a dramatic reaction in water to make potassium hydroxide and hydrogen. That's the word equation. And this is what the symbol equation would look like. So potassium is K, water is H2O, and potassium hydroxide is KOH, and hydrogen is H2. Now we can see here that hydrogens seem to be the problem because the potassium atoms seem to be okay and the oxygen atoms seem to be okay, but unfortunately 2 hydrogens here, 3 hydrogens here, it's not going to work. So first of all I'm going to increase the amount of hydrogen on this side because we don't have enough. So I'm going to put a 2 in over there. Put a 2 there. So now we have 4 hydrogens on the left, 3 on the right. Not enough, but I can easily increase the number here by changing the amount of potassium hydroxide that I produce. So now we have enough hydrogens. On the left we have 4, and on the right we have 2 here, and we have 2 here, that's 4. So also the oxygens are okay because I've doubled the amount of oxygen on the left and on the right, so that's good. Unfortunately the potassiums now are not okay, but I can easily rectify that by putting a 2 in front of this one. Balanced. 2 potassiums, 4 hydrogens, 2 here and 2 here, and 2 oxygens there, 2 oxygens there. That's all good. Let's look at another one. Nitrogen plus hydrogen makes a substance called ammonia, and we have nitrogen, which is also diatomic, N2, plus hydrogen, which we know is diatomic, which makes ammonia, which is NH3. So we have not enough hydrogen on the left because we have 2 hydrogens, 3 hydrogens on the right. We have too many nitrogens on the left, only 1 nitrogen on the right. Let's start off by doubling the amount of ammonia so that we balance the number of nitrogen atoms. So let's start off by putting a 2 in front of the ammonia here. So now the nitrogens are balanced, but the hydrogens are not balanced. On the left we have 2 hydrogens, and on the right we have 2 molecules of ammonia, so that's 2 times 3, that's 6 atoms of hydrogen, and only 2 here. How can we make up the difference? How can we make this into 6? We need to put a number in front, 3. So now we have 3 molecules of hydrogen here, that's 6 atoms of hydrogen, 6 atoms of hydrogen here, 2 atoms of nitrogen, 2 atoms of nitrogen, balanced. Let's carry on with a couple more examples. Sodium plus oxygen gives us sodium oxide. So sodium is Na, oxygen is O2, and sodium oxide must be Na2O, because we know oxygen has 2 spaces in its valence orbital, sodium has 1 electron available in its valence orbital, so we're going to need 2 sodium atoms to supply the electrons necessary for the oxygen. So that's the correct chemical formula. Now we can see here that it's not balanced at all, so we need to address that problem, and we can start off by doubling the amount of sodium oxide that we produce. And now the oxygens are balanced, O2 and 2 oxygens here. We've got 4 atoms of sodium now on the right, and we can easily change that on the left by just putting a 4 here. 4 sodium atoms, 4 sodium atoms, 2 oxygen atoms, 2 oxygen atoms, balanced. One more example. Aluminium plus chlorine becomes aluminium chloride. So let's take a look at that one. Aluminium is Al plus chlorine, another diatomic gas, Cl2, becomes aluminium chloride, which is AlCl3. Now this one might look slightly trickier. Let's see what we can do here. Aluminium is balanced already, but the chlorine is certainly not. We can't put 1.5 here to balance the chlorines because these have to be whole numbers. So let's start off by trying this. Let's put a 2 in front of this and a 2 in front of this. Now the aluminiums are still balanced. The chlorines are not balanced, but the balancing is now going to be easier. Whereas we couldn't put a 1.5 in front of this, now we've doubled the other compounds. Double 1.5 is 3. We can put a 3 in front of this. Let's put a 3 there. 3 chlorine 2 molecules, that's 6 atoms of chlorine there, and 6 atoms of chlorine here. 2 times 3 gives us 6 chlorines there. 2 aluminiums, that's balanced. So now it's over to you. Now I want you to do these two by yourselves, bring them to the next lesson, bring your answers to the next lesson. So we've got sodium hydroxide plus sulfuric acid, gives us sodium sulfate plus water. This is the chemical equation, balance that. And the second one, iron plus water, gives us iron oxide plus hydrogen, iron oxide being a form of rust. The symbols Fe plus H2O gives us Fe3O4 plus H2. So do those yourselves, please, balance them, and bring your answers to the next lesson.